Hey everybody, in this video we are going to talk about piecewise and step functions. This first part of the video is going to focus on step functions. We're going to talk about the parent step function and then kind of what happens as you mess about with it and change things with it and all of that. So let's get started. All right, so what a step function is it's a graph that looks like a bunch of little like line segments, right? And a lot of times you'll see like dots and then open unfilled circles and things like that. It is a linear function because it does move in a linear fashion, sort of, but it's not a linear function in the continuous sense of what you think of being a linear function. So they call it a piecewise linear function. So it's a linear function in the sense that it's made up of separate linear functions, but there's pieces of it. All right? So the first one we're going to look at, and this is the main one you're going to look at for step functions, is called the greatest integer function. So what it means is that they're going to give you this function, this f of x, and then we're going to introduce this new kind of bracket notation here that looks like this. They're going to give us this function, and what that means is it says where f of x is the greatest integer not greater than x. So like if I put 1 in for x, right? If I put 1 in, that's going to return a value of 1, and then you would graph 1. If I put in 1.5, the greatest integer that's not greater than this would be 1, right? And anything all the way until you get to 2, so even 1.9999 would give me a value of 1. So it's almost like it's a round down sort of function. That's the way I think of it. So we are going to look at what does that look like for a graph, all right? So if you put 0 in, right, it's going to just be 0. If I put 1/2 in, it's going to round down to 0, so that would be here. And anything before we get actually to 1 is going to be along this line here. So you're going to get this thing, and I'm going to use red, that looks like this. And then when you actually get to 1, it doesn't include 1 because when you hit 1, it goes up to 1. So we put a round, an empty circle, denoting that it goes up to that point but does not actually include that point. And then for 1, same deal. If I put 1.5 in, it's still going to stay on 1. If I put 1.25 in, it'll stay here, and it's going to remain that way until you get up to here, and then it's going to wind up looking like this. And so if you go through this, you're going to wind up having a graph that's comprised of a bunch of segments like this that apparently my iPad is deciding to be really difficult again. And it's funny because I've got a new one I'm working with, right? So you're going to get something that's going to look like this. And then it will go down in the opposite direction too. The negative doesn't change it, right? So it just kind of goes on and on and on and on like that. And so you get something that's like a linear progression, right? But it's made up of pieces. Okay, so let's try some other looks at this now. So this is our basic kind of parent function, is what we'll call it. So let's take a look at what some of the other ones look like. So if I got this one right here, all right, I've got this f of x is equal to this x and then minus 2. So basically you think about what we had and then I'm going to subtract 2 from it. So if I put 0 in, it's going to put me at 0, but if I subtract 2, that puts me down here. So 0 for x puts me there. And if I put 1/2 in, that still rounds me down to 0, so you still have 0 minus 2. So this doesn't change between 0 and 1, and it stays the same. So your overall output stays the same, so it will stay there. And so effectively what it does is it takes this entire graph and it shifts everything kind of down 2 units. And we call that a transformation. What is going on? This thing is being really difficult. It's like it doesn't like the way I'm circling or something. It's kind of weird. All right, maybe I'll try another stylus while we're doing this. All right, and then so it'll continue to do the same thing going in the other directions, right? All right, so now let's look at this other one here. So this one's, you know, it has the potential to be kind of interesting. So if I put 0 in for x and then do my 0 minus 2 first this time, right? So 0 minus 2 gives me negative 2. So I start out with the same value. If I put 1/2 in, 1/2 minus 2 gives me negative 1.5, right? But that's bigger, and it's not an integer. So it's still going to wind up looking almost exactly the same. Well, not almost exactly the same. It is going to look exactly the same. All right? So you wind up with basically the same function, and you can see that it doesn't really change the look of it, how it's written in this case. All right, now let's take a look at some other ones. So we are looking at what happens when we multiply inside the brackets and when we multiply outside the bracket. And this would be an inside one, this would be an outside. So let's start with the outside one. So if I put 0 in, right, it's going to give me 0. If I put 1 in, it's going to give me 2. If I put 2 in, it's going to give me 4. And now let's look at what happens to these middle values. All right, so if I put 1/2 in for x, now before I can multiply it by 2, I have to realize I have to make this the greatest integer that's not greater than x. So that would move it down to 0, right? So that would be 0. And anything before I get to 1 is going to get moved down. So what you're going to wind up with now is you're going to wind up with this piecewise function that's similar to the other one, but it's a little more spaced out. All right? So you get this. All right? And then your next one would go up here. And then something I want to talk about really quick is they're going to ask you about your domain and your range on these. And when you do domain and range, it's just what values can you put in. And in all of these, your domain up to this point has been x, and then so this is the set builder notation. And then it's just all real numbers, right? It's all real numbers. Okay, but your range changes with each of these. And you'll notice that your range here is it's only integers, and it's also only integers that are multiples of 2. So I would say all integers, and then if it's a multiple of 2, that means it's divisible by 2. Divisible by 2. And that's what you would have for this one. If we quick go back and look at these other ones, this one would be your range. Remember, your domain for all of these is going to be, you know, your all real numbers. That's another way of writing all real numbers, is an R with an extra line through it. But your range for this one on the left is just all integers, right? Because it is all integers. Y will it'll go all the way down to negative infinity and up to positive infinity, but it's only hitting the integers. And you have the same thing for this one as well. It's just shifted over. Okay, so let's move forward. Now let's look at the second one here. So when I put 0 in, again, it gives me 0. When I put 1 in, it gives me 2. So it looks like, it sort of looks like it's doing the same thing. But now if I put 1/2 in, I get to multiply this first before I evaluate, do the integer function to it. So if I go 2 times 1/2, I get 1. Well, that is an integer. So what you get is it kind of breaks this up into chunks now, like this. So you're going every time you get to a half, because if I put 3/2 in, right, which is 1.5, I get 3, and that will move me up there. If I put 2 in, it gives me 4, and then you'll continue to get something like this. So it's still a piecewise function, but it's broken up a little differently. All right, and so that's kind of the way it looks. Your domain, again, is going to be all real numbers, or you could write it like this, or you could even just say all real numbers. And then your range is going to be, in this case, it's all integers, right? All integers. Because you are using odd integers now. You've got 0, 1, 2, 3, 4 going up this way, and then going down it's the -1. So it's all integers again. Okay, let's look at one last example here. Okay, so we've got this thing that says f of x is equal to -2 times, and then in the greatest integer function we have x plus 1, and then we're subtracting 3 from that whole thing. So this looks a lot scarier than it really is. Let's just put 0 in and see what happens. So let's write it out. So you get 0, it's going to look like this. 0 plus 1 minus 3. All right, well, if I do this, and I put 0 in, it gives me 1, right? And then the 1 is an integer, so that's good. So you have -2 times 1 minus 3. So that gives you -2 minus 3. So for 0, you get -5. So I'll go 1, 2, 3, 4, 5. I go down here. I put a dot. And you can see if I put 1 in, right, that's just going to change this number right here. So that would become 1. 1 plus 1 is 2. If this would be -2 times 2, which would give you -4, and -4 minus 3 gives you -7. So that would move me down here. All right, sorry, I'm going to shift this just a little bit. All right, that moves me right down there. All right, now let's look at what's happening in between. All right, so if I put 1/2 in, right, it doesn't really matter what I'm doing, but what it's going to do is the only way. Let me see, how can I put this in a way that makes sense? The only way that the whole thing is going to change value is if this changes value. And this is only going to change values on regular integers. So it'll stay the same from 0 all the way up to, but not including 1. It'll stay the same for 1 all the way up to and not including 2. So you're going to get the same kind of piecewise function that you had before, where it's going to return the exact same value all the way up here and then not include that point. All right, and then if I want to draw a few more, I would go like that. And so you would say to yourself, all right, and it's going to continue up that way. You'd say, all right, well, the domain, again, is all real numbers. But then for your range is weird because it's not all integers because we're not including 0, 2, 4, 6. So it would be all odd integers because all your y values are all going to be odd numbers. And that's kind of fun, if you think about it. So that's how these step functions work. Don't overthink them. They're not that confusing. Just if you can get your head wrapped around that integer function, then you're in good shape. All right, next, piecewise functions.